4 billion years ago, Mars was not the barren world we see today. Imagine blue skies, thick clouds forming over continents, rivers carving through red rock, and an ocean, a real ocean, stretching across the northern hemisphere. This wasn't science fiction, this was Mars. Thanks to orbiters, rovers, and decades of study, we now have a surprisingly clear picture of the red planet's ancient geography. And it was far more Earth-like and far more violent than anyone expected. Let's rewind Mars to the world it once was. The Grand Ocean begins in the north, the Vastistas Borealis Basin, a massive lowland covering nearly 40% of Mars's surface. Today, it's a frozen plain, but billions of years ago, it held a vast ocean called Oceanus Borealis. The clues are written everywhere in the landscape. Long, curving boundaries marking ancient coasts, thick sediment layers where waves once settled, river deltas still frozen at the edges of vanished bays, and soil chemistry showing minerals left behind by evaporating seawater. In 2024, China's Zhurong rover added the strongest evidence yet: sedimentary structures that form only in shallow coastal water. It was the closest thing to a snapshot of an ancient Martian shoreline. At its peak, this ocean may have held more water than Earth's Arctic Ocean, plunging a mile deep in places and spreading across much of the northern hemisphere. But something about it puzzled scientists. The shorelines weren't level. Some stood thousands of meters higher than others. The breakthrough came when researchers realized the planet itself had shifted. Mars experienced true polar wander, its outer layers slowly tilting over time, distorting anything that was once horizontal. Correct for that tilt, and the coastlines lock perfectly into place. Not everyone agrees the ocean was permanent. It may have appeared during warm periods and frozen during colder epochs. But the weight of evidence leans toward a simple truth. Mars once held a real ocean, even if it came and went. If there was an ocean, something had to feed it. Look at the southern highlands, a branching network of valleys etched into the terrain like veins. Some were quiet river channels, others were gigantic floods, events so powerful they carved features hundreds of kilometers wide. Regions like Caseval and Ares Valles were shaped by torrents that may have carried more water than 1,000 Amazon rivers flowing at once. Volcanic heat melting buried ice, collapsing underground reservoirs, and asteroid impacts likely triggered these sudden floods. But Mars didn't only flood, it also rained. Many valley networks resemble terrestrial river systems formed by long-term precipitation. That means ancient Mars likely had clouds, rainfall, and seasonal cycles, at least during certain warm periods. And these rivers are old, more than 3.7 billion years old. While Earth was still recovering from relentless asteroid bombardment, Mars may already have had lakes, deltas, and flowing rivers. The volcanic monsters. If water shaped Mars, fire built it. Olympus Mons, the tallest volcano in the solar system, rises 22 kilometers high and spans 600 kilometers across. Stand at its base, and the summit would hide beyond the horizon. Mars grew volcanoes this large because it lacks plate tectonics. On Earth, shifting plates move volcanoes away from their hotspots. On Mars, the crust stays still, letting lava erupt in the same place for hundreds of millions of years. Nearby, three more giants, Ascraeus Mons, Pavanus Mons, and Arcia Mons, form the Tharsis Montes. Together, they sit on a volcanic plateau so massive it literally tilted the planet, altering climates and redirecting ancient rivers. These eruptions released enormous amounts of greenhouse gases, temporarily thickening the atmosphere and warming the surface. Mars may have cycled between warm, wet periods and long, frozen epochs. its habitability flickering on and off like a cosmic heartbeat. The Grand Canyon of Mars. Now travel east to Valles Marineris, the largest canyon system in the solar system. 4,000 kilometers long, up to 200 kilometers wide, 7 kilometers deep, and in places even more. Unlike Earth's Grand Canyon, this chasm wasn't carved mainly by water. It was torn open. As the Tharsis volcanic region swelled, the crust fractured. The ground dropped between widening faults, creating a planet-scale rift valley. Later, water joined the story. Sediment layers suggest ancient lakes in the canyon's depths. Massive landslides, some larger than the entire Grand Canyon, thundered across the floor, traveling hundreds of kilometers thanks to Mars' thin atmosphere reducing friction. Standing on the rim, the opposite wall would be so distant it curves out of sight. You would be looking across a scar in the planet's crust, a wound that has remained open for billions of years. Where did it all go? So how did this watery, volcanic, Earth-like world become the frozen desert we see today? Mars didn't die quickly. It faded. The turning point was the loss of its magnetic field. Around 4 billion years ago, the Martian core cooled and convection slowed, collapsing its magnetic shield. Without protection, the solar wind stripped the atmosphere molecule by molecule. As the air thinned, temperatures fell. Oceans froze. Rivers dried up. Moisture escaped into space or retreated underground. The blue world slowly turned red. But the water didn't vanish. It's still there. Locked in polar ice caps, buried in glaciers across the mid-latitudes, and possibly pooled in liquid reservoirs deep below the surface. A dead world can still hold the memory of life. Every rover brings us closer to answering the question we care about most. Did Mars ever host life? Jurong revealed coastal formations. Mars Express detected deep sediment layers consistent with long-standing water. Perseverance is zoo, collecting samples from an ancient river delta. Samples NASA plans to bring back to Earth. If microbes once lived in Martian lakes, rivers, or underground vents, traces of them might still be preserved in these rocks. Mars and Earth began as siblings. One stayed alive. The other went quiet. But silence doesn't mean emptiness. Ancient Mars wasn't always red. It was once blue, dynamic, warm, shaped by water and fire. And somewhere beneath its frozen dust, the remnants of that world, and maybe the remnants of life, still wait to be found. If you want to explore more worlds like this and dive deeper into the mysteries shaping our solar system, subscribe. Space Atlas is just getting started, and the next discoveries may change everything we thought we knew.